This is a desert. Daytime temperatures here climb past 40 degrees Celsius. And 2,400 years ago, people living here made ice. On purpose. In bulk. No electricity. No refrigerant. No moving parts. Just an understanding of physics. This is how they did it, and why engineers are rebuilding the same idea today. It's called a yakshal. In Persian, it means ice pit. The oldest date to around 400 BC. The dome could stand 18 meters tall. Beneath it was a deep pit carved into the ground. The walls were built from saruj, a mortar of sand, clay, lime, ash, goat hair, and egg whites. At the base, those walls were over 2 meters thick, almost waterproof, almost heatproof. But the clever part wasn't the dome. It was what sat next to it, a long shade wall. In the shadow of that wall sat shallow pools. Workers filled them with water at dusk. By morning, there was ice. They cut it into slabs and hauled it down into the pit. Here's the strange part. The air temperature often never dropped below freezing. The water froze anyway. It got colder than the air around it. So where did the heat go? Everything with a temperature glows. Not visibly, but it glows. We can't see it. Our eyes only read a thin slice of the spectrum. But it's pouring off you right now. Your body, your coffee, this screen. All of it constantly leaks heat as infrared light. We can't see it. Our eyes only read a thin slice of the spectrum. But it's pouring off you right now. So a pool of water in the desert is doing this too. It's radiating heat upward into the sky. Normally that's pointless. The atmosphere absorbs most infrared and radiates it straight back down. But the atmosphere isn't sealed. There is a gap in it. Physicists call it the atmospheric window. Between 8 and 13 micrometers, the air is essentially transparent. That infrared just leaves. It doesn't stop at the clouds. It doesn't stop at the edge of the atmosphere. It goes to space. And space is cold. The background temperature of the universe is about minus 270 degrees Celsius. So a shaded pool on a clear night has a direct line to the coldest thing that exists. It dumps heat into the void faster than the air can warm it back up, and it freezes. You've seen this happen. Frost on your windscreen on a morning that never hit zero. The car under open sky frosts over. The one under cover doesn't. Same air, different sky access. But this only ever worked at night. During the day, the sun ruins it. Sunlight dumps roughly 1,000 watts per square meter onto any surface facing it. You radiate about 100 watts away. You absorb 10 times that. You lose. For a century, that seemed final. Then in 2014, a team at Stanford asked, what if a surface could do both jobs at once? They built a mirror out of stacked nanoscale layers, each one tuned to a specific wavelength. It reflected 97% of sunlight, and it glowed hard in exactly the 8 to 13 micrometer window. In direct midday sunlight, it sat 5 degrees Celsius below the surrounding air. That had never been done. 7 years later, engineers at Purdue University did it with something much simpler: paint. The pigment is barium sulfate, a cheap compound used in cosmetics and photo paper. They packed it with particles of many different sizes, so it scatters the entire solar spectrum. The result reflects 98.1% of sunlight. Ordinary white paint reflects 80 to 90. In full midday sun, it stays about 4.5 degrees below air temperature. At night, over 10 degrees below. Water is pumped through them, chilled by the sky, and fed into a building's refrigeration system. coat a 1,000 square foot roof, and researchers estimate 10 kilowatts of cooling. That beats most home air conditioners. This is already commercial. These panels look like solar, but they run in reverse. Water is pumped through them, chilled by the sky, and fed into a building's refrigeration system. At a California supermarket, a 60-panel array cut refrigeration energy use by 15 to 20%. Nearly 20,000 kilowatt-hours saved. No electricity in. No water evaporated. No noise. It isn't magic. Clouds and humid air close the window. This works best where the sky is dry and clear, which is exactly the climate the Persians were living in when they figured it out. 24 centuries apart. Same physics. A clear path to the coldest place there is. The universe has always been an infinite heat sink. We just had to stop blocking the view.